Hi, and welcome to Calculus Examples. Today we're going to look at a problem where we're finding the absolute maximum and absolute minimum values of this function 2x cubed minus 3x squared minus 12 plus 1 on the interval -2 to 3, inclusive of those endpoints. So when we talk about finding absolute maximums and minimums, right, that means that we're going to be looking at critical numbers. So that's the first thing that we're going to notice from here. We don't use the word critical numbers, but that's what it means that we're looking for. And critical numbers occur when we have our derivative is equal to 0, or our derivative does not exist. Now I put a c in there instead of an x because we're looking at a specific point, call it c. Now, just as an example, our derivative doesn't exist. So one good example of this, and you've probably seen this in most textbooks, would be if y is equal to absolute value of x. So here's an example there, and we see our derivative here at our center point is going to be not existing because it's at a point, but at the same time, it is a minimum. Okay, in this situation, we have a polynomial, so we know that it's going to be continuous, which means we only need to take the derivative and figure out where it's equal to 0. So find those points. So let's start off with that. We're going to have our function, and polynomials are so wonderful to work with when we're taking derivatives. They're just straightforward. It's lovely. So we're going to take our derivative with respect to x, and we are going to end up with 2 times take our power down, subtract 1 to get our new power, and we're going to do that with each term here. I'm going to do this piecemeal. You'll notice I'm taking probably a lot more time than you will when you go through this, and that's okay. I encourage you to do the quick math in your head if it works for you. 2 times 3. I just want to make sure that we all see the steps here. 6x minus 12. Remember our last number, that plus 1 on the end disappears when we take our derivative. All right, so we have our derivative. We're going to set this equal to 0, and we're going to solve for x. So setting it equal to 0, one thing you notice, it's a quadratic function, so we are going to factor it. However, there is this factor of 6 in every single term here. So I'm going to start by just pulling that 6 out because it's going to make our lives a lot easier. When you have an integer that you can pull out of every single term, do that because it's going to make the work easier. It's not going to affect your solution at all. All right, so now we're going to break this up. It's a quadratic. We just need to factor it. If you want to use the quadratic formula, you go ahead, do that. I'm going to go a little bit quicker on this. We have 2 numbers that multiply to a -2 and add to a -1. So the only 2 numbers would work would be 2 and 1. Next question is, what are those signs in the middle? So what do we put here and here? Are they plus or minus? We know one of those signs has to be positive and one negative because our output here, our last one, we multiply the 2, we get a -2. So one of them has to be negative, but since our middle term is a minus x, we want to have a -2. So we've got a positive 1. All right, when we multiply things together, one of those things has to be 0. So that is going to give us our different solutions. And we can kind of ignore the 6, which is great about this at this point. If you want that to be a part of this, it's not going to affect the solutions. So here are our 2 critical points. So these are our critical numbers. The question is now, which ones are going to be absolute maxes and which ones are going to be absolute mins? So we want to figure out max or min. And to do that, we're going to punch those numbers into our original equation. Now, one thing to notice is that if we had not been given an interval, and you'll notice that these two numbers are actually in our interval, which is from -2 to +3. Oops, let's do a +1 there, a little bit nicer. So we have 16 minus 12 minus 24 plus 1. So that is -19. Uh, they are in our interval. If we didn't have an interval, these might be local maxes or mins, not necessarily global. Well, in fact, because it is a cubic function, it would be local but not global. -1 cubed minus 3, -1 squared minus 12, -1 plus 1. So -1 cubed is a -1, so we get -2 for our first term. And then we subtract 3 because -1 squared, our negatives cancel. -12 times -1 is a +12 and plus 1. So this is going to give us a +8, which means that we have a maximum at x is equal to -1 and a minimum at x is equal to 8. Whoops, not 8, at a +2. There we go. All right. Thank you so much for listening.